Okay, this should be part 7 of backup power supply. Now, I'm not going to talk about all my calculations here. I'll maybe include those in the pinned comment. But I got 147.5 watts worth of light bulbs there because I burnt out one of my 60-watt light bulbs in a trouble light and had to put another one in there. But that's okay. Now, they're connected. The two sets of light bulbs are connected in parallel and they're also connected to the transformer bank. And that's not going to work properly because it's the wattage that goes through the transformers that goes to the bridge rectifier charges the battery. It doesn't include the current needed for the light bulbs. But I think, yeah, sure, it will probably last longer. And I got two batteries. They're connected in parallel. Yeah, they're connected in parallel. I got the booster cables on them because I have the battery charger here. They're connected in parallel through the truck, but I got the battery charger, charging them both through the cables. And these cables are, I'll have a look here. I'll just turn this off for now because I want to demonstrate it with just the batteries on. Yeah, the cables come here. Yeah, so both batteries are feeding the inverter. And then, of course, they're being charged at the same time, too, through the bridge rectifier. So I'm going to turn it on to show it, make a few measurements, and we're going to see if these heat sinks get hot. So I got, it shows, the battery shows right now 12.26 volts. And it should go down a bit as soon as I turn it on. There's the bulbs coming on. Yeah, it's gone down. And it'll go down some more, but it seems to stabilize. And gets lower. Yeah, slowing down now a bit. So it stays on for a long time. Went down to about 10.4 before, and the verge still stayed on, which is amazing. It's supposed to turn off at about, I don't know, less than 12. Yeah, you can feel a tiny bit warming up already. So I'll do some another voltage test here. Turn it to AC. Okay, we're testing AC. Okay, something's not touching here properly. There it goes. 118.54. Oh, almost 119 volts. My calculations, I used 118 volts, I think. Okay. So now, let's make a few current measurements. Just check these diodes. Oh yeah, they're getting pretty hot already. Check these probes here. Nope, the clips aren't getting as hot. Yeah. Okay, I'll just turn it off for a moment. And I'll get the ready on here. Okay. And yeah, it's the current in the DC. That are on. And current 7 point something coming out of the bridge rectifier. And now we'll try the current going into the inverter. Is going to be, should be up pretty high, I think. Oh yeah, look at that, 30, 29. DC 30, yeah. Yeah, those top ones aren't as warm. Okay, we'll just measure the current, AC current coming out of that wire there from the transformer outputs, and it's about 8 amps DC, and it's about 12 volts. It's about 12 volts DC coming out. See here? Yeah, 13 volts. My finger here. Yeah. 13 volts. AC coming out. Okay. So, I guess that's all I need to talk about. Oh, right. What I'm going to be doing next is dismantling this. And I'm going to be using diagram 3 and one transformer here to create 240 volts. And this transformer bank is going to be connected in series with the light bulbs. So these two will be in parallel with the connected in series with the transformers. Then the same current going through the total amount of bulbs is going to go through the transformers. And then it should supply the right current going back to the batteries to keep it charged. So I hope that works out. I was delayed for quite a while there during the winter because something made me very sick and affected my throat. That's why my voice is sounding kind of funny. Yeah. Okay, so I'll work on this as soon as I can. Thanks so very much for watching. Good night.